Hello, everyone, and welcome to the December online viewing session of the Kalamazoo Astronomical Society. I hope you can all hear me, and it is great to see you all here tonight. I do want to apologize for having to postpone one night, but it really should be Mother Nature that should be doing the apologizing. I did check our all-sky camera, which I'll show you here shortly, at about 8:30 yesterday when we were supposed to start the session. And, you know, the forecasts did call for mostly cloudy skies, but it was totally socked in. It was completely overcast. And it was pretty cloudy until midnight our time. So it's a really good thing we did cancel the session yesterday, or at least postpone till today. But it is a beautiful day in Portal, Arizona, but even better, it's a really cloudy and cold day in Michigan. So that makes it a great day to be inside and check out our remote telescope out west. So again, I want to thank you all for joining us. It is an absolute pleasure to have you here today. So let's jump right into it. Let's do a little weather report. Let's see what the current conditions are out there. I'm going to do my first screen share here. And the first screen that you'll see is the computer that actually controls the telescope out in Arizona. So this is the Observatory Computer, as we call it. And you can see all the programs running here, but we're going to look at clarity up in the upper left corner here. And you can see the current temperature is about 56 degrees rounded off. So that's pretty pleasant compared to what we have here. The wind is about 5.5 miles per hour. We always got to keep an eye on the wind out there because we don't want it to go over 10 miles per hour, because that's when the scope will park itself. And I didn't change the upper limit of that. So if it does hit 10, it might park itself, but I'll maybe try to remember to change it later. And you can see the humidity is very nice, 38%, or no, that's 36%. I need a new prescription. So conditions are looking pretty good. The wind is our usual nemesis, but it's supposed to stay calm, but oh, now it's up to 6.1 miles per hour. See, now we're in big trouble. That shouldn't be too bad. So let's go back to our main screen here. And we'll give you just a little tour of the facility. So this is where the KAS Remote Telescope is located. If you attended the session last month, I gave a more in-depth intro to everything. So this time I'm just going to kind of highlight anything, but of course, at any time, if you have any questions, just please feel free to ask. So here we see the home of the remote telescope. It's called Pleiades Observatory, which is Apache for Nighthawk. And it's a 20 by 20 roll-off roof observatory owned by KAS member Mike Patton, who is with us here tonight. And you can see, just kind of peeking out there, the remote telescope. So that's where the telescope is located. And I just gave the weather report. And of course, the weather comes from this station here. But what we're going to look at next is our all-sky camera, which you can see right here. But here's a close-up of our S-Big all-sky 340C camera, which again is an all-sky camera with a fisheye lens. And we mainly use this camera to check out the current weather conditions. So let's check out the all-sky camera. I got to find my browser. It's one of these slides here. Let me get on the right screen there. You guys don't want to see my email screen. Okay. Too many buttons. There we go. So there is the current view of the all-sky camera. And of course, you can go to this webpage here. I can scroll up here. You can just go to the Kalamazoo Astronomical Society website, basically 24 hours a day between October and June, because we shut the scope down during July, August, and September. But you can go to our website, go to the remote telescope menu, and pull up the Pleiades all sky camera, which is the page that we're on now. And you can see how the sky looks above Pleiades Observatory in southeastern Arizona right now. So let's give you a little bit of a tour here. The first thing that usually catches people's attention is this funny structure in front here. This is actually a bird perch that we installed because, you know, the birds kept landing on the dome and leaving bird, you know, residue behind. And so we thought they might enjoy the perch a bit more. So we put that on there, and sure enough, they use it, and they tend to spend more time on the perch now than they do the dome. But if you're lucky, you'll catch the occasional bird standing on the all sky camera dome there, which is kind of hilarious. We've caught some birds of prey on there as well. I don't know how they fit on there, but somehow they do. And in the upper right here, which is actually the northwestern sky, you can see Mike Patton's house. Oh, and they just turned the lights out, and you can see the page just reloaded. We take a 1 minute image every 4 minutes. So I have the page, the web page here, reload every 4 minutes, but of course they're not in perfect sync here, but we should be good here for 4 minutes or so. And so of course you can really see the Milky Way here. That's really starting to come out, but we are kind of getting away from Milky Way season here as we get into the, you know, more of the fall sky. We get into galaxy season. But of course, what really might catch your view in the sky is this bright source right there, and that is none other than the planet Venus. And you can see that above the mountains here. I want to say they're the Davis Mountains, but that's West Texas. But this would be the kind of Cave Creek Canyon Mountains there in the background. And you can see another bright source here, which is Jupiter. But right between Venus and Jupiter is Saturn. And you can see that the three planets, Venus, Saturn, and Jupiter, are on this nice straight line. And they'll pretty much be this way the entire month. So if you actually have clear skies, you can go out and see this for yourself, but we can enjoy this right here. So let's check out some constellations or asterisms. We have the dominant summer triangle up here. We have the bright stars Vega, Deneb, and Altair. And of course, they form the summer triangle. Vega is in the constellation Lyra, which is a really small constellation, relatively speaking. It's basically a little isosceles triangle and a parallelogram. And then over here we have Deneb, which is the tail of Cygnus the Swan, which makes up the Northern Cross. It kind of goes to here toward Albireo, a very pretty double star that we often look at during the summer. And there's kind of the cross kind of goes this way. And then these are supposed to be the wings of the swan as well. So we have wings, tail, and kind of a head here. And then we go down to Altair, which is the head of Aquila the eagle. And you can see a little triangular structure around it with Altair at the base, between the two stars at the base of the triangle. And that's the body of the eagle, Aquila the eagle. One wing goes kind of straight out here, and the other's kind of bent back. This little red thing's a hot pixel. You know, the camera gets a little warm during the day, so it takes a little while to cool off. And then you can go from the tip of the triangle here down to a couple stars that kind of mark the kind of tail feathers of the eagle. So the eagle's kind of flying this way, while the swan's kind of flying toward the mountains there. And then you can see the Great Square in Pegasus. So we have the 4 stars of the Great Square, but actually only these 3 stars belong to Pegasus, while this star belongs to the constellation Andromeda. And so Pegasus, the winged horse, is actually upside down as we see it in the sky. There's the back of the winged horse here, so you can imagine a wing, but there are no stars that represent the wing of the horse. And there's kind of a open triangle here for the head. This is like a tip of the head. And then there's a leg kind of going off to here and a leg going off to here, but it's a little hard to see with being so wide. And then basically Andromeda is just 2 arcs of stars. And you can see this little clump here. This is the Pleiades, and we have the Hyades, and we will take a close look at the Pleiades tonight with the Takahashi. It does a really good job. And of course, where all the planets are is the constellation Capricornus. So it's kind of hard to see Capricornus. It kind of looks like a Cheshire cat smile or something like that. Oh, there we go. It reloaded again. And so you can see Capricornus, and then from the top of Capricornus, we can kind of go over here for Aquarius, which is again tough to see, but you can kind of make it out a little bit. So there's a quick tour of the sky. Oh, I should mention, we also have the constellation Andromeda as well, which is that famous W-shaped constellation. And you can even see one winter constellation here, Auriga the Charioteer, which we'll check out a little later in the season. And right toward the edge of the camera here is where you can see the North Star, but the Big Dipper is too low because we get a bit of a cutoff here on the northern horizon. But that's just kind of the way the chip works. So let's go back to our other screen here. Here we go. Whoop. Doesn't switch back for me. There we go. So we always tend to start with our Takahashi. On a very rare occasion, I'll start with the plane wave, but I know most people come for the plane wave, the big scope. So we kind of save that as a main event. But the first telescope we'll use tonight, one half of the remote telescope, is our Takahashi FSQ 106 EDX3, which is a 4-inch refractor with a SBIG STX 16803 CCD camera. So these cameras are fairly high end. They are now discontinued because everyone's kind of transitioning into CMOS. At least the manufacturers are. And one of these days we may do an upgrade, but this is still an extremely good camera. It is a full frame camera, as you can see. It basically has a 37 millimeter square chip. So it's a good size chip. You know, in terms of today's standards, the megapixels might be a bit on the low side, but really for astronomy, it's just fine. Resolution for astronomy isn't everything. And with our kind of slow internet out there, we don't want tremendously huge file sizes to have to upload to our cloud account where our images go. So for now, this camera is just fine. And as I'll show you later, and as you'll see, it takes extremely good images. So this will be the camera that we'll be using tonight. It's on both telescopes. So let's see what the telescope is actually doing right now before we go to our first target. We'll show you the Pleiades webcam. So this camera shows live inside the observatory. And of course, you can really see the 20-inch here, but this little white thing here with the flap open, that's our Takahashi. So this is the telescope, again, we'll be using to take pictures with first. And so you can basically see the inside of Pleiades Observatory now. And we'll try to check in on the telescope from time to time, especially when it slews, because that's when it's really exciting, because otherwise it just slowly tracks and takes pictures. Okay, so our very first target tonight is kind of an unusual subject. As we'll see, it's not really a it's not really a constellation or an open cluster or anything like that. It's something a bit different. And so our first target is going to be Colander 399, or also known as Brocchi's cluster or Al-Sufi's cluster, but everyone likes to call it the coat hanger cluster today, or just the coat hanger. So it has several names. And this was actually first described by the Persian astronomer Al-Sufi in his the Book of Fixed Stars in the year 964 CE. And it was actually independently rediscovered by the Italian astronomer G.B. Hodirna in the 17th century. But in the 1920s, Delmiro Francis Brocchi, an amateur astronomer and chart maker for the American Association of Variable Star Observers, the AAVSO, created a map of this object for use in calibrating photometers, because of course they use those to measure the brightnesses of these clusters. And so in 1931, the Swedish astronomer Per Callender listed it in his catalog of open clusters, but as we'll see, that wasn't there, but he didn't know that. And it's basically located with basically within the summer triangle, maybe just on the edge of the summer triangle. You can just draw kind of a line between Vega and Altair here, and that'll kind of take you straight to it. With the unaided eye, you can see it as kind of a fuzzy patch, you know, maybe near these more obscure constellations. Vulpecula, the fox, is a bit tough to spot with the unaided eye, but Sagitta, the arrow, isn't too bad to spot at all. So it's pretty easy to identify. Again, you can see it with the unaided eye as a patch. It's a great target with binoculars. And as you'll see, it's a great target with the Takahashi. But here it is in a little more detail. So again, it's located almost halfway between Alpha Vulpeculae, which is up here, and Alpha Sagitta, again, as kind of a molted haze. So that's where we find it. So now we actually have to go to the target. So let me go back to the screen here, the browser, if I can find it. And we'll click on that there. And you can see this is the browser interface for a program called ACP, which is what controls the programs that control the telescope. So this is kind of your Swiss Army program that works with many, many other programs. And we'll scroll down here and you can see I already have it typed in. So Callender 399 is abbreviated CR 399. I did hit get coordinates, but I'll do it again because I have a habit of forgetting to do that. And then I'm going to take a 5-minute exposure with our luminance filter. So let's go ahead and begin to acquire the image. And of course, what will happen here is the telescope will hopefully, unless the image froze, it'll begin to slew to our target. I'm just going to go ahead and hit reload just in case it did freeze on me. Because again, the internet can be a bit slow out there, so it can freeze. There we go. So you can see it in matrix mode here, as I like to call it. But now the telescope is slewing. So as soon as it gets to the target, it'll take a sample image to do what's called plate solving, and then it'll perfectly center the target. It'll look for an a guide star, and then once the guide star is acquired, it'll begin to take the image. And it shouldn't have any trouble looking for a guide star because we're right in the Milky Way. So there's quite a bit to see there. So it looks like it's already reached this target. It is kind of in the summer triangle. So it's getting low now. So this is really kind of our last chance to look at this during the online viewing session, but this is actually a new target. We haven't looked at this object before. So we can hop back to the observatory computer. I think it just took the 20-second framing image, or the plate solving image. And there we go. Now it's looking for a guide star. So you can see it has many guide stars to choose from. And it'll pick one. And then it'll have to get, you know, situated, little calibrated, and then it'll begin taking the picture. So from here, I'm going to stop the screen. And if anyone wants to unmute themselves and say hi, or tell us where you're from, or ask a question, now would be a great time to do that. So again, welcome everyone. Let's hear from you.
Hey, Richard, just wanted to thanks for hosting tonight.
No problem. It's my pleasure.
You here? Oh,
Yep. Hello, everybody.
Hello there.
we're from Des Moines area.
Iowa.
Oh, great. Corn country.
That season's over, thank you.
Yes.
Hi, Richard, Joy, and Rick from Eureka.
Hi, Rick.
Yep, California.
Richard, would you refer to that brooches as asterism?
That's exactly right. You're jumping ahead of me. Yep. As we'll see, it's not an open cluster. It's just kind of a random grouping of stars. which is an amazing coincidence considering the cool shape that it makes.
Hi, Rick. Hi. I would like to say hello to Linda Wilkinson, who is also a member of our club.
Oh, great. I don't know if she'll say hi back. It'd be polite.
Maybe. Turn this off.
When you did first enter the Zoom room here, you were not able to unmute yourself, but obviously you are now. I changed the settings, so it'd be great to hear from everyone. Or if you have any questions about the telescope, astronomy, KAS, stocks. No, don't ask me about stocks. I don't know anything about that. I'm terrible with money. Well, let's check in and see how we're doing. We can see the program run. So it looks like we have a guide star. The guiding could be a little smoother, but hey, beggars can't be choosers. And we are taking our image. So you can see the progress here. So again, this program here is called ACP, which stands for Astronomer's Control Panel. What really controls the telescope is kind of a couple of programs. Since we have a software BISC mount, we use the SkyX, a desktop planetarium program from software BISC to control the mount that actually points the telescopes. But to control the camera and the autoguider, we use a program called Maxim DL. We have to use Maxim because that works with ACP. And again, ACP can basically control Maxim and the sky, and another program called Focus Max that helps us focus the telescopes, which I did manage to do tonight with time to spare, unlike last month because daylight time wasn't over yet. And so I was waiting for it to get dark enough to begin focusing the telescopes, and barely got it done in time. And what I would really appreciate is when we do bring the image up, when I click on the image here, because this is another image from another night, and go ahead and unmute yourself, because we love to hear the oohs and ahs instead of just absolute silence. So we would like to know that you're there, at least with some oohs and ahs.
Are the images black and white?
Yes, unfortunately, they're going to be monochrome. It takes time to take color images through like red, green, blue filters and process them. So these are not color cameras because we use these cameras for more high-end imaging. It's best to do that in monochrome because monochrome gives you much higher resolution as it would for a straight to color camera. So yeah, they will not be in color.
Thank you.
You're very welcome.
There's a question in the chat, Richard.
I was just looking at that. Yeah. So yeah, can you explain the it's called full width half maximum, and that's basically a measure of the scene. And of course, we haven't done any images yet to base the scene off yet, so that'll come up later. Hopefully, it'll be around 2 or 2.5. That's where we usually get. Although 1.5 would be really good, but we rarely ever do that. Okay, so you can see it's 2 seconds past. I don't know why it does that. It only does that in ACP. It doesn't do it in Maxim. All right, so go ahead and unmute yourself, everybody.
All right, I'm unmuted.
All right, here we go. All right, so there's the thumbnail. It takes a second for the actual image to get processed.
Yeah.
So we'll give it another second here. There we go. I heard a little bunk. All right. Oh, that's that cannot be right. So, all right, here we go. You ready?
Ready.
There it is.
Oh, nice. There you go. All right.
Very nice.
Wow.
Ooh,
Ooh, wow.
That's a hanger.
Upside down hanger.
Yeah, I see that.
So that's where my hanger went.
I'll show you in binoculars later.
Yeah.
Oh, I'm not muted.
All
How
right.
far away is that?
Good question. So as Mohammed gave away, this is not an open cluster. So you can see the stars of the coat hanger here. There's basically 6 here with 3 or 4 under, I guess you can say 4. And so this is the coat hanger. And of course, you can see lots and lots and lots and lots of stars right in the disk of our home galaxy. So it was discovered in 1998 by Brian Skiff, I believe at Low Observatory, to be basically an unrelated group of stars. So it is just an apparent asterism. And as you can kind of, as I mentioned, it's basically an asterism. You know, we call it the coat hanger, but we can, you know, with asterisms, there are no rules. So it's an asterism made up of 10 stars ranging from 5th to 7th magnitude. And there's a straight line, of course, of 6 stars and 4 stars that make the hook. Now, of course, the distance, because the stars are not related, they have a lot of different distances. I don't know the distance to each star, but it varies between 354 to 2,237 light years. So 354 light years to 2,237 light years. So a huge range of distances for these stars. So they are absolutely unrelated to one another, which just always mesmerizes me because it's such a cool structure. I personally tend to call it the Mommy Dearest cluster. If you've ever seen the movie, you know, no wire coat hangers. So that's my little personal nickname for it. But if you look closely, besides the actual coat hanger and all the stars in the Milky Way, there's an actual open cluster right there. I forgot to make note of it on the chart earlier because I didn't put it in my notes. Let me bounce back to my notes here. That is the cluster NGC 6802. Now I lost my screen. That one there. So it's basically 17 arc minutes and 33 arc seconds east of 7 Vulpeculae, which is the easternmost star in the coat hanger here. So it's just like 17, 18 arc minutes away. So very close. And it looks pretty roundish here, maybe a little elongated. So because through telescopes, it does have an elongated appearance. It's about magnitude 8.0, has a diameter of 5 arc minutes. And this cluster here is about 5,800 light years away. So that's a bonus object there. How about that? And don't forget, at the end of the night, I will give you a link to download all the images tonight. Of course, if you're a KAS member or you are on the online session viewing list, you already have the link. And I should be able to process these pictures tonight once we're done and get them up here probably by midnight. But if you don't get them by, tomorrow afternoon, you can send me a hostile email, where are my pictures? So I'll do the best I can. And the images that you will get will be full resolution. So you can really zoom in and see more detail than you can see here. Because it would take time for us to retrieve the images from our cloud account, download them, and do a little processing. So this is actually kind of a reduced a thumbnail there. So that is our first target for tonight. And while we're on this screen, let me put in our next target. It's going to be IC, or Index Catalog 1848. And make sure I hit get coordinates because I am really bad about that. We're going to make this a 10-minute exposure with the H alpha filter. And we're going to hit acquire image and off we go. All right, we should be back to the KAS logo. So yes, this is our next target, IC 1848, otherwise known as the Soul Nebula. And the nebula itself is actually formally designated Westerhout 5 or Sharpless 2-191 or LBN 667. And you can see it's about magnitude 6.5, but that is very deceptive. It is an incredibly faint object. And this is one of the reasons why we really like doing online viewing sessions, because we can look at objects like this that you otherwise really can't observe very well through a telescope. And you can see this is a nebula, obviously, about 7,500 light years away. And we'll basically see where it is. It's technically in the constellation Cassiopeia, you know, the W-shaped constellation. But in this case, in this configuration, it looks more like an M, although it is pretty close to the constellation Camelopardalis, the giraffe, but the border of Cassiopeia extends way out here. So this gives you a rough idea of where we're looking at. But more specifically, using a scan from Sky and Telescope's Jumbo Pocket Sky Atlas, which I highly recommend, we can see it's located about 4.5 degrees north of Eta Persei, which is right here, or 2.5 degrees southeast of the more famous Heart Nebula. So the Heart Nebula, of course, is right here. That's IC 1805. And we have looked at that before, but we've never done the Soul Nebula before. So this is our first time doing the Soul Nebula tonight. And there are several small open clusters that are embedded in the nebula. You can see many of them labeled here, but they include Colander 33, 34, plus Colander 632 and 634, which are not shown on the atlas. Those are located in the head of the Soul Nebula. So basically, there's also a small emission nebula called IC 1871 found left of the top of the head, and the small emission nebulae 670 and 669 are just below the back area, which are also not quite labeled here. So we should see a lot more nebulosity than just the main region here. So again, this is an emission nebula, and they have several other names. They're known as H2 regions because they're composed of molecular hydrogen, but they're also known as stellar nurseries because it's these emission nebulae like the Heart Nebula and the Soul Nebula, known as the Heart and Soul together, that are known as, you know, regions of star formation. So I thought we should spend a little bit of time here, since we do have a 10-minute exposure ahead of us, briefly talking about where these nebulae come from, because you might wonder how they actually form. And there's one idea called the density wave theory. So the density wave theory proposes that spiral arms are waves of compression that move around the galaxy, as in the Milky Way, triggering star formation as they go. So you can see along the front of the spiral arms here is the density wave. And so because these waves move slowly, orbiting gas clouds overtake the spiral arms from behind. So if you do look at images of galaxies, you know, nice, pretty color images of galaxies, you can usually see that the emission nebulae, the nice red patches, are right at the front of the spiral arm. But you might wonder where the gas comes from in the first place that runs into the density wave. And of course, it comes from supernovae, or just stars spewing off material into space as they age or, you know, really begin to die. And so all this gas and dust that's spewed into the interstellar medium collects at the fronts of spiral arms, and a lot of that gathers into emission nebulae like the Heart or the Soul. And of course, we'll check out the Soul tonight. So that's a quick little bit of science of where emission nebulae come from. So let's see how we're doing here. Let's go back to the ACP screen. And we have our guide star. Oh, the guiding looks much better. And we can see we have a bit of a time to go before we complete the exposure here, because longer through H-alpha filters the better. But while we're on the browser, let's go back to the tab here and check out the sky. It's good to check on the sky conditions here. Our all-sky camera is really meant for weather. It's not really to look for meteors, you know, because it only takes an image every 4 minutes or so. But we'll check back from time to time. or of course, you're welcome to check this on your screen at home. And if anyone spots a meteor here, let me know. I've yet to see a really bright meteor. We've caught plenty of faint ones, but never like a really bright, showy one. And again, if you're joining us a bit late, you can see Venus, Saturn, and Jupiter in a nice straight line here. We'll be losing Jupiter here probably in the next 10 minutes or so.
Isn't that Venus?
What did I say? Venus? Did I say
It's a Jupiter.
Oh, I get it backwards. Yeah, the really bright one is Venus. The other, the next second bright one is Jupiter, and Saturn's in the middle. All right, folks, so we got plenty of time to chit chat. So I was going to mention to our friends from Iowa that after we installed the Takahashi in March of 2017, some of us did the long drive home. We tried to do it in one trip, but we decided to stop at a rest area in Iowa and take a nap, and it was pretty cold. So yeah, so I know what you mean by being cold there. Yeah.
Very good.
I had a question about the star chart or the star map.
Sure.
Do the green areas represent nebulae there?
Yeah, let me go back to the PowerPoint and we can back up and take a look. Of course, it does come with a key, but I don't include that in the picture. We'll have to back up. Oop, a couple there. Yeah, so basically the green here means nebulae, while the yellows are clusters.
Oh, I see.
And if there's I don't see any here, but that doesn't surprise me. If there's kind of a circular green, oh, there's one, of course, the little dumbbell. This is a planetary nebula. And pretty much, the odd ones are, the odd shaped ones are larger nebulae, and the smaller squares are smaller emission nebulae. And, we're looking right into the Milky Way, so there are no globular clusters to see in this part of the sky.
Richard, what is the name of this software or whatever is that?
Oh, this?
Yeah.
This is a scan from Sky and Telescope's Pocket Sky Atlas. It's a hard copy chart that I scan and show here for a little more detail.
Oh, okay. It's not a software. I thought it was
no. So it's not software.
Thank you.
But like this image here, this is from Starry Night.
Okay.
I specifically have Starry Night Pro, which gives you a realistic view of the sky.
Okay.
There's our density wave theory graphic again. All right, so let's go back to the browser. If I can get to it, let me. No, that's not what I want to do. Boy, it is. We'll just stop sharing. It is so hard to change browser tabs because the Zoom stuff gets in the way. All right, we're about 400 seconds into our picture. 200 seconds to go. I see Linda said hi in the chat, so she's too shy to say hi anything. Well, you guys are a shy group compared to the folks we had last year.
I have a question.
Sure, Kathy.
So you said the Starry Night Pro, but I don't think you can get that on Apple. Is that it?
I believe it is available for Apple, yeah. I only have an iPad. So I have Sky Safari for my iPad, but I'm pretty sure Starry Night's available for the Mac too. Somebody can do a quick Google search and check on that for me, but I'm pretty sure.
Yeah, I think that's correct. It's a computer program, not a iPad or iPhone.
Yeah.
Okay, that's why I can't find on.
And of course, if you want a desktop program for free, you can download Stellarium. That's an excellent program. Doesn't cost a thing.
Yeah, I do have that.
Oh, great. Yep, Starry Night's pretty good too. There are several levels. We have the amateur astronomer version on the observatory computer here in town for our owl observatory. And we use that to control them out there.
Hi, my name's John Kane. I'm a new member.
Hi, John. Oh, yes.
And this is thanks for the email the other day. It's my first time joining a group like this, to observe through a telescope. I've seen it done before, but it's the first time I've ever joined, and it's great to see that you guys. I was a little I didn't understand at first that you were in Michigan and the scope's in Arizona, but now I understand the explanation. Yeah, that one of the members had. Very nice. Yeah.
Yeah, if the scope was in Michigan, we'd be totally canceled.
No, I understand. I used to I live in Milltown, New Jersey, but I did for a year. I was doing a lot of business out in Arizona, and I've vacationed out in like Sedona, and the sky is beautiful out there at night.
Yeah.
Yeah.
Yep, you can see Mike Patton here in the Zoom room, and he's right in the warm room of the observatory.
Hi, Mike. Very nice setup you got there.
Thank you. I had to figure out how to unmute myself. It's a nice night out here tonight.
Yeah, it's overcast here in New Jersey. It was clear last night, but that's all right.
We should be getting there. Oh yeah, it's like 14 seconds. All right. This gives a little view of the guide star we or the program chose, but this does not change as it guides, unfortunately. All right, looks like we're done there. So what happens, of course, is the image has to download from the camera. Maxim creates the thumbnail and then processes the larger version that we actually look at. So there's the thumbnail, then we have to wait for the bonks and then it'll be done. So there's a little work going on in the background as we speak here. Bonk. All right, you guys know the routine. Let's unmute ourselves. Here we go.
Yeah, that's very good.
There we go.
Oh,
Nice. Oh, wow. That's art.
And before anyone says it,
Very nice.
another obvious name for the Soul Nebula is the Fetus Nebula, because yes, it looks like a fetus.
Oh, boy.
So-
It does look like a baby.
Yeah, if you look at it sideways, if you turn your head sideways, it's kind of ghostly.
Yeah.
Yeah.
So what is all that cloudy stuff?
Well, it's mainly hydrogen and helium and a trace of the other metals, everything else in the periodic table, basically. So let's give you a few little fun facts here. The heart and the soul together span an area about 300 light years across. So you can just see the top of the Heart Nebula here.
Is that you moving it?
No.
And of course, this is the actual Soul Nebula. And the Soul Nebula itself is about 100 light years across, at least on the long end. And the stars in the region are less than a few million years old because, again, this is a region of star formation. So a lot of the stars you see around the nebula are very young. And like any nebula, it's shaped by stellar winds from stars embedded within. And it's home to W5, which is a radio source that spans an area roughly the size of 4 full moons. So if you had eyes the size of wagon wheels and could see in radio waves, it would look very, very different. And the radio source has large cavities that are the result of nearby massive stars as winds and radiation carving the nebula, pushing the gas together and causing it to ignite to form new stars. This is a process we call self-sustaining star formation. You know, in this case, It's the energetic light and solar wind from newly born stars that push the gas around and give rise to even more stars. So studies have shown that the stars are progressively and systematically younger the more distant they are from the center of these cavities. So kind of like tree rings, there's a story to be told here. Any questions about the Soul Nebula? I think we did have one there.
So this is not an emission nebula, then it reflects the light of stars. Is that right?
It is an emission nebula. It is.
Oh, it is. Hmm.
It'll have a little properties of both. Most nebulae have a little of both in them, but mostly what we see here is emission nebulae because we're using our hydrogen alpha filter, and emission nebulae or H2 regions give off most of their light in I'm just gonna hit the mute button there. That they give off most of their light in H alpha. So we could take an image of this with our regular clear filter, but it looks much, much better in H alpha, trust me. And I always like to point out, yeah, it does look like a little baby or fetus. And of course, there's a little piece of poo there, baby poo. That's what it looks like to me anyway. So it's a young baby with no diaper, but that's good. All right, we have one more target with the Takahashi. So while we're still on the screen here, let me type it in. And you should all know this target, I hope. And this time, I think we'll do 5 minutes, although even 3 minutes looks pretty good. But let's go ahead and do 5. And we'll hit acquire image there. And we'll talk a little bit about it. So yes, our third and final target for the Takahashi is M45, the Pleiades, or Subaru, or the Seven Sisters. And so you can see, of course, the right ascension declination here, but it is located in a pretty well-known part of the sky. And the Pleiades is only about, as you can see, 444 light years away. And I always tend to, I forgot to mention this with the first two, but I always like to show a sketch drawn by an amateur astronomer, just to give you a sense of what these objects look like when viewed visually through a telescope, as opposed to what they look like with the remote telescope. So you can see this is a sketch by a good artist named Ronnie Delott. He does lots and lots of very nice sketches. So of course, the Pleiades is famously located on the back of Taurus the Bull. We can see the face of the bull here, the familiar Pleiades. I blanked on the name there. And we can see it here in a little more detail. But we can even switch to the even closer chart there and see the Pleiades in more detail. So I hear the camera's working in the background. So let me just tell you a little bit more here. So again, this is referred to as the Seven Sisters after the 7 doves that carried ambrosia to the infant Zeus, or the 7 sisters who were placed in the heavens so they might forget their grief over the fate of their father Atlas, condemned to support the sky on his shoulders. And we can usually see about 6 stars with the unaided eye, but we refer to it as the 7 sisters. But there are 10 stars brighter than 6 magnitude, and the famous observer writer Stephen James O'Mara logged 17 Pleiades, members of the Pleiades, from, of all places, Cambridge, Massachusetts. So if he can do it from Cambridge, spend some time one night looking at the Pleiades and see how many you can spot with just your eyes alone. Maybe you can do more than the usual 6 or 7. And obviously, because it's so prominent in the sky, it's been known since ancient times in cultures across the world, including China, Japan, Persia, Maya, from the Cherokee, Aztec, Sioux, and Aborigines. The Japanese mentioned it as Mutsurabushi, which means 6 stars, in documents dating back to the 8th century. And they also, again, know it as Subaru, meaning coming together or cluster. So when you see a Subaru car, it has that little star emblem on the hood. That's why. It is mentioned in the Iliad, Homer's Odyssey, the Bible, and the Quran, among other texts. So obviously the Pleiades is very well known. So let's go back to the ACP here and see how we're doing. Looks like we're chugging along. We got a guide star. And we're acquiring photons as we speak. Oh, and we just reloaded the camera. Let's see if we have anything good. I think if you look here, you can see a bit of a glow here. That does look like the zodiacal light. As we get closer to the winter solstice, the zodiacal light will be much more prominent. The zodiacal light is basically dust in the plane of the solar system that the sunlight reflects off of. We used to think it came, or kind of still mainly think it comes from asteroids and comets that leave bits of dust and debris behind through impacts and other mechanisms. But there's a newer study that suggests that the zodiacal light, the dust from the zodiacal light actually comes from Mars of all places. But exactly how you get dust off of Mars into the plane of the solar system is still kind of unknown. So that's a new fun idea. And you can see Venus is gone. So that's kind of sad. But we do get a replacement. You can just now see Orion the Hunter rising from one of the few light domes on the horizon. So yeah, we even got a little bit of light pollution from this Bortle 1 site here. But it is very dark. Don't worry about it. So again, here's where we're taking a picture right now. That's the Pleiades right there. And we'll see it much, much closer here shortly. Well, there we go. And I forgot to go check in. Let's just go peek in on it and see how we're doing there. There it is. So you can see the current configuration of the telescope. And if you ever check the all sky camera and it's a nice clear night, you can go back to the Pleiades Observatory webcam page here and see if we're using the telescope that night. Some of us try to use it every clear night. And you can see when the flip flap is open, that means we're using the Takahashi. But if this is closed, then we're probably using the big scope. And you can see here's our club logo that a neighbor at Arizona Sky Village made for us. And this little funky thing here, this is our flat screen for the big scope. The flat screen for the Takahashi's built in and the flip flap there. It's called the flip flat because it can take flats.
Richard, how do you change the filters?
There's this device here is a filter wheel. So there's like a whole carousel row of filters on there. It contains 7 filters in all. There's a luminance filter, red, green, blue, hydrogen alpha, O3, and sulfur 2. So we're using all 7 slots. And let me tell you, those filters are not cheap, especially the narrowband filters. We use 3 nanometer slit Astrodom filters, the best. Good stuff. Oh, looks like we're done there. So don't forget, time to unmute yourself. Got to hear some oohs and ahs. Oh, now it's 3 seconds past. That is so weird. I don't know why it does that. So say goodbye to the baby.
Ooh.
Look at that.
Nice.
Wow.
Yeah.
Wait till it gets big.
And that's only the thumbnail.
Yeah.
There we go. Ready?
Yep.
Here we
Yes.
go.
Yeah. Oh, very nice. There you go.
Oh,
Fantastic.
Wow.
Wonderful.
Look at that.
Very
Look
good.
at the
There you go.
nebula.
That's pretty cool.
Look at all the bitty
Lots of
stars.
nebula.
I want that for my Christmas tree.
I saw that Pleiades for the first time when I was about 10 years old through my dad's refractor telescope, and it nearly knocked me over.
Oh, fantastic. All right, let me tell you a little bit about the Pleiades here. And then I have one more thing to share related to this. The Pleiades is 100 million years old and composed of hot blue, highly luminous stars belonging to spectral type B. At least those are the bright ones anyway. It contains approximately 100 stars in a sphere about 15 light years in diameter with a tidal radius of about 43 light years. And a total population is over 1,000 stars, not including unresolved spectroscopic binaries. So there could be even more. The cluster will survive for about another 250 million years. What happens as these clusters orbit the galaxy, they encounter alien stars, or they plow their way through dust and gas, which is what they're doing right now, and they gradually lose members. And of course, some of the more massive members, like those B-type stars, just might die. So open clusters don't usually last billions of years. They can, but typically open clusters like the Pleiades last hundreds of millions of years. And you can see there's lots of reflection nebulae around the brightest stars. And this was once thought to be, material left over from their formation. But now we know that the Pleiades is just passing through the Taurus Auriga complex of dark nebulae. I remember way back in the mid-90s reading the paper in the Astrophysical Journal that announced that for the first time, that this gas and dust has nothing to do with the formation of the Pleiades. And after I read it, I went back to the physics department where I was a student at and talked to an astronomer friend, Kurt Karista, who's also a member, and he didn't believe me. But he eventually heard or read about the paper himself, and now it's kind of known as a fact that the Pleiades is just passing through a really dusty region in the Milky Way. And like many clusters, it contains many brown dwarfs that make up about 25% of the cluster's total population and less than 2% of the total mass. But don't expect to see any brown dwarfs here. You really need an infrared telescope to see them. So yeah, it's amazing what a 5-minute picture can do of the Pleiades there. Now, I've been trying to get this to catch on for years, but I'm trying to call this little string here. You see this little string of stars? I'm trying to call that the bell string. I'm trying to get that to catch on for totally egocentric reasons, because if you missed it, my last name is Bell. So here we go, bell string. Come on, people, make it catch on. Next time you share this with somebody through binoculars or a telescope, say, hey, there's the bell string, and eventually it'll catch on. Any more questions or comments about the image here? All right. So again, while I'm on the screen here, I'm going to scroll down here, way down, and I'm going to click this script here, and we're going to begin to switch to the big scope. So we'll go back up here, but there is one more thing related to the Pleiades that I want to share with you. Here we go. So we very rarely ever show color images unless they come from the remote telescope. So I'm happy to share with you, many of you may not have seen this yet because I didn't show it until October, which is the same time I processed it. But here is a color image of the Pleiades taken with the Takahashi we just used to take that image just now. So here it is. So this was taken with our telescope.
Wow.
Incredible.
Yeah.
It's great.
It's wonderful.
How did you do this process going from black and white color?
Sure. Okay, so you can see we have the Astrodom filters here. So I took there's 12 times 5 minutes, 300 seconds each through luminance filters or luminance filter, which is a clear filter. So basically the filter we just used to take the picture. And then I took images through red, green, and blue filters. So the luminance gives the detail, while the RGB, the red, green, blue, that gives the color. So then you use a program. I used a program called PixInsight that automatically, aligns and stacks the image, and then I processed it with PixInsight and then a little bit with Adobe Lightroom to really help bring the color out. And I can show you a close-up. So I cropped this a bit. This isn't quite the full resolution, but here we are a bit closer.
Oh,
So yeah, we only share images like this when they come from our telescope. So there you go. Prints are for sale in the lobby. No, not really, but I wish we had a lobby with prints, but we don't. Okay, so now we're gonna switch off to the big guy, our Planewave CDK20, which is a 20-inch corrected Dole-Kirkham telescope. That's what the CDK means, corrected Dole-Kirkham. So yes, it does have a 20-inch primary mirror. It uses the exact same camera. So it also uses an STX 16803 CCD camera with the same set of filters in our filter wheel. This is the focuser, a Finger Lakes Atlas digital focuser. Then we have a device here called an on-axis guider. I can answer more questions about that here later. And then this is our current auto guider, but we just got a new auto guider in on Friday that Mike Patton said he's going to pick up for us at the post office on Monday, because our newer auto guider will have 5 times the field of view of this older one here. So that'll hopefully make looking for guide stars much easier. And I mentioned our mount. So here's the mount before we put the scopes on. This is our software bisque Paramount ME2, which holds both the 20-inch and Takahashi. So quite a bit of weight, but it has a 240-pound capacity. And we're probably at about 200 pounds of that. So we're not quite anywhere, we're nowhere near really tapping the capability of this mount here. Okay, so let me go back to the screen here. And we've switched telescopes. So I got the successful model there. My scroll on my mouse isn't working. And let me type in the designation of our next target. So we're going to do another obscure one. Well, it's a popular target, but not one that's easy to observe. And I think we'll stick with 5 minutes there. Although we could do 10. Oh, what the hell? Let's do 10 and see what happens. Actually, I do have custom coordinates for this. I almost forgot, because I want to frame it a certain way. Well, I don't want to, but I kind of had to, because for some reason I had trouble finding the guide star when it was centered, which I found hard to believe. You'll see what I mean later. But this does frame it in a very specific way. All right, so there we go. So I'll hit the acquire image. Everything looks good. And off we go. Did I hit it right? I don't think I hit it right. Nothing's happening. Okay, let me try it again. There we go. Okay, now I see the log screen here running right. So let me go back to the PowerPoint. And we'll introduce our target. So our target is IC 5146, the Cocoon Nebula, another new target for the online viewing session tonight. So this nebula is also cataloged as Caldwell 19 from the Sir Patrick Caldwell Moore catalog, or Sharpless 2-125. IC 5146 is actually an open cluster of 9.5 magnitude around bright stars and dark nebulae, also known as Colander 470. But most people refer to the Cocoon Nebula as IC 5146. But again, technically, it refers to the open cluster. It was discovered by the British clergyman and noted double star observer Thomas E. Espin on August 13th, 1839. And it's located way toward the back of the constellation Cygnus here. I think it's technically in the constellation Cygnus. Yeah, it is. And so you can see it's quite some ways from the actual constellation Cygnus. And we'll move into detail here. Last month, if you joined us last month, we did the North American Nebula, NGC 7000. And so we're going to work a little further north this time. So it's located about 2.5 degrees east-northeast of the 4th magnitude pi squared Cygni, which you can see up here, or 4 degrees east-southeast of the well-known open cluster M39, which is right there. There's the dark nebula Barnard 168 forms a dark lane that surrounds the nebula and trails westward. And that's why I typed in custom coordinates, because number one, I would really want the nebula centered, but for some reason I couldn't find a guide star during my rehearsal the other night. Yes, I do rehearse these to make sure we can get guide stars and all that, but for some reason it couldn't find one, and you'll see why that's so surprising here shortly. And so I moved it so we have a bit of the dark nebulosity in the image, but you got to take a lot of images for it to really pop out there. All right, so now we go back to our transition screen here, and we'll hop back to the, and oh wait, I forgot to do something. I'm gonna hit stop run here. I knew I was gonna forget. Okay, so let me show you what I forgot to do. Because we switched telescopes, I forgot to change the focal lengths in ACP. So I got to change the aperture, and I got to change the focal length, because ACP can only work with one telescope at a time, unfortunately. So it looks right. I'm going to hit that and go back to the web browser, and I'm just going to go ahead and hit it again.
Is this a reflector telescope?
It's a reflector. Yeah, it's technically a compound telescope, kind of like in the same family of Schmidt-Cassegrain. But but yeah, it's mostly a reflector because it doesn't really have any lenses except for the corrected part in corrected Dol-Kirkham. It's basically a lens group in the back that helps correct the image a bit.
Thank you.
Yeah. So it's more reflector than it is anything. All right, so you can see we're taking our 20-second framing image. Maybe we can get a look at that here. We'll make that go away. Sometimes it pops up so fast you can't see it. Up, you can see a little bit of it. It's not there long. It does its plate solving and pretty fast, and then it's done. So I can rearrange the screen here a little bit. And there we go. Lots of guide stars this time. I'll move that down here. And we should be good here. There we go, much better. Okay, so I had one mess up tonight. I forgot to change the aperture and focal length. I do that a lot. I really got to make a sign here in front of me like, hey, stupid, change the aperture and focal length because you're going to forget. All right, so we're well underway here, but I decided to go ahead and do a 10-minute shot, see if we can really bring it out. So we certainly have plenty of time for chit chat or questions or comments or anything like that? Are you guys having a good time?
Richard, earlier we asked about the Starry Night Pro.
Yeah.
I'm wondering that is something available only to Celestron owners?
I think Celestron might come with a lower, like the student version of the Sky, but I don't remember.
There is a college version that is for educational purposes.
Yeah, because there are like 3 different levels of Starry Night, but I don't know. I thought the Celestron came with maybe the Sky instead, because there are several versions of the Sky too.
This is John. Yeah, I just picked up a CGEM Mark II, and it came with the Celestron SC, and I happen to have iOS, Mac, iPad, and right away I got coupons. When I picked up Safari, they were also offering a discount to upgrade to Pro on the Celestron with a 50% off coupon. So it was pretty easy to get it all together. Okay,
great. I used to know all this stuff back when I was a dealer, a telescope dealer back in the early 2000s, but I've forgotten all the stuff they come with now.
Can you operate your telescope from anywhere? If you have a portable computer?
Yeah. I mean, here's a great example, right? I'm in Kalamazoo, Michigan. The telescope is in Portal, Arizona, about 1,800 miles away. So yeah, telescopes can be controlled from either. You can either, set up your telescope in your backyard and control it from inside. That's really great during a Michigan winter when it's clear and incredibly cold. So absolutely. Some of it is Wi-Fi now, but especially when you're doing imaging, the Wi-Fi connection is not really reliable. I've kind of found that out with our observatory because I tried controlling our telescope and camera via Wi-Fi, or at least the mount via Wi-Fi, and I've had issues.
If one of us were imaging with both telescopes, would we have to remember to switch the focal length and aperture as well?
No, unfortunately, we encourage users to stick with one telescope.
Gotcha.
Because we don't give anybody else access to the observatory computer, because we've heard horror stories from other clubs, like little smart kids that think they know everything trying to tinker with your computer. This one kid in a club just to the north of us kept changing their computer over and over again. They finally had to ban him from the place because he would not leave their computer settings alone. And so, it took a lot of effort for us to get this set up. So we don't want anyone else getting on the computer out there. Only really 2 of us get onto the observatory computer routinely.
Just delete system32.exe and you're fine.
I'm not going to do that. That sounds bad. I'm not sure what that is. That sounds terrible. But anyway, if you when you sign up to use the remote telescope, if you choose both telescopes, I set it up for the plane wave, because the Takahashi still points pretty well, but when ACP is set up for the Takahashi, the plane wave doesn't point well. So that's where you run into the problem. It's usually within the target anyway, but still, it's better to stick with one telescope.
Thanks.
To use your telescope, you have to be a member?
You do have to be a member of the Kalamazoo Astronomical Society, and to use the remote telescope, you have to live within Southwest Michigan. I'll show you the region here at the very end, but it's basically in all the surrounding counties around Kalamazoo County, and of course Kalamazoo County itself.
Okay, so Indianapolis doesn't qualify.
Not right now. No, we may eventually expand outward a little bit because we have quite a few members that have signed up to use the telescope, but when it actually comes to using the telescope, not too many yet. Maybe half a dozen using on a regular basis. 2 of us use it a lot, and that one of those people is me. The other is Henry. How's it going, Henry? I do got to apologize to poor Henry. I forgot to put the cloud date on the calendar, and he reserved the telescope for tonight. And I had to bump poor little Henry. I feel terrible.
It's fine.
He says it's fine, but you know it's really not. You could hear the frustration in his voice.
Do you do the training for anybody who wants to use the telescope?
We used to do live training, but now we have a training video.
Oh.
And we have a user manual. I think
So
it's a very excellent written user manual. Just personal comment there.
But it probably would take a while for you to get it
Actually
going, right?
the scope itself is really easy to use, but the real challenge comes in the processing. That's where the challenge is. Yeah, that's one reason why members have been hesitant to use the telescope. They think it's really difficult, but as you can see me here, it's really easy. Let's see how we're doing. We're a little more than halfway there.
I think Henry was working on a mosaic of the Orion Nebula. Like that? How's that coming?
Henry?
Yeah, I am. I haven't shot anything in a few days though. A week about.
And Henry, did you sleep through the night you were going to get the comet next to M3, or what happened there?
I was gonna shoot a dark nebula instead, but it wouldn't guide, so I shot Andromeda with the plane wave.
Okay. Shoot, I would have probably got you to do the cluster with the comet. We could have done some pictures of that and got some good publicity. Oh well. We're getting there. Oh, I should probably peek in the, I don't see any.
Comet is getting brighter, and I believe towards the end of this month and first week of January, you should be able to see it much more clearly.
Yep, of course, it is visible. You know, someone did email me today and hope we could see the comet during the session tonight, but it doesn't get high enough to do anything with until just before dawn. And of course, remember, we're in Kalamazoo. The scope is, 2 time zones away, so they're 2 hours behind us. So we have to wait a little longer for dawn to come out there. So it's even worse. But it's maybe a little better because it's kind of getting up around normal time for us. We're getting there. Maybe I should have done 5. Oh well. It'll probably be worth it. We can look at the Pleiades again. There we go. I forgot to mention, if we scroll down and look, it's probably gone now, but when it does the plate solving, it tells you how many stars are roughly in the image, but I don't see it. It's probably here somewhere.
So with more exposure time, did you get a better picture, better resolution?
It depends on the target, but the usual answer is yes. Of course, the longer the image, the more signal you get, and that's the battle with imaging, is you want to fight noise and get signal. So if your image is too short, then it's really noisy. Yeah.
Richard, I have a question. Did you say that the particular stars we're looking at, the Pleiades, have always kind of been one of a bunch of started at the same time and about the same age, and they're moving together?
Exactly right. Yeah, that's with open clusters, they all have the same approximate age, chemical composition, and distance, and proper motion. But
thank you.
But where they differ is mass. So they'll age at different rates. The more massive stars will die off first, and then the older and older stars will begin to go. But that takes a lot of time, of course. All right, we're done. Let's see how we do here. There we go. That looks pretty good. All right, here we go. You ready? Our first target with the plane wave.
All right, excellent. Look at it.
Oh, yeah.
Good deal.
Yeah. Oh, you can see that dark lanes.
Yep. Oh, yeah. 10 minutes looks much better than 5 minutes, which is what I did before. So, yeah, I'm glad I did that.
Nice.
Very nice. Very nice.
So the nebula's true diameter is about 15 light years. The massive central star, which formed about 100,000 years ago, which is incredibly recently for stars, provides the energy source for much of the emitted and reflected light from this nebula. So again, this thing here cranks out so much UV light, it excites the gases around it and causes them to glow. So that's basically what an emission nebula is. And the central star cataloged according to Sky Safari is Cousteau 2320, but it's also known as BD plus 46 3474. Everyone write that down. And it's a ninth magnitude binary star, spectral type B1V. So it's a pretty high-end B-type star with a surface temperature of 25,450 Kelvin. And it's about 12.6 times the mass of our sun, or about 7.2 times the radius of our sun. So this sucker is a big, big star. And you can see some of the dark nebulosity mentioned. Barnard something. I forgot the Barnard number for this one, but you can't see the dark nebula. It trails off pretty far, but maybe one year we'll do an image of the cocoon with the Takahashi where you can really see the dark nebula trail off into the distance. But can you see why I was shocked why I couldn't get a guide star? I mean, look at this. It's, it's crazy. So that's one of the reasons why we're getting a new guide camera. But yeah, that's quite beautiful, don't you think? And obviously it's called the Cocoon Nebula because it's in that dark cocoon of dark nebulosity. Any questions about the Cocoon Nebula? All right, here are none. We'll close that for now. Scroll down and type in our next target while we're here. Now, I was going to do the helix, but man, it just does not look good in a picture. I think we'll knock it down to 5 this time. 5 should be good enough. And there we go.
Do you keep the same filter for?
Yeah, I pretty much take most of the images through a luminance filter, maybe H alpha. I tried to do H alpha for the Cocoon Nebula, but it just didn't look very pleasing. All right, so let me introduce you to our next target. We're going to do NGC 7331, the Deer-Lick Galaxy. That's kind of a name I gave it because it's part of a well-known group of galaxies called the Deer-Lick group. So I always wondered, where did this name come from? And so I did a bit of research a while back, and reportedly, Tom Lawrenson, author of 1000 plus, the Amateur Astronomer's Field Guide to Deep Sky Observing, gave the group its name in honor of the Deer-Lick Gap in the mountains of North Carolina. So that's where the Deer-Lick group of galaxies gets its name from. And they're actually, the other 4 members of the Deer-Lick group include NGC 7335, 7336, which are both unbarred spirals. There's NGC 7337, a barred spiral, and NGC 7340, an elliptical galaxy. And these are affectionately referred to as the fleas. And you can probably see this is 7331 here in the sketch, which is uncredited because I couldn't figure out who exactly sketched it. And you can see many of the fleas around the Deer-Lick group there. So we're going to go over now to the constellation Pegasus. So we're going to be right above the front leg there of the winged horse itself. So that's roughly the part of the sky that we're going to look in. But more specifically, from our pocket sky atlas, it's located about 4.5 degrees northwest of Eta Pegasi, or Matar here. I believe that's how you pronounce that, which is beneath the flying horse's front legs. You could really say above, but remember the horse is flying upside down. So this galaxy is specifically a regular barred spiral galaxy. I did not make note anywhere of the specific galaxy type of this one, but it's definitely not a barred spiral. And it's not one of the elliptical galaxies. So here we see Hubble's galaxy classification scheme. And I believe NGC 7331, if I had to guess, it's probably an SB type spiral galaxy. Oh, we'll just skip that. That's more for ellipticals anyway. We're talking about spirals. All right, let's see how we're doing. I can never go back to the telescope in time. So, but now you can see we're going to look a lot higher, which is good. Higher is better when it comes to taking pictures, because the higher it is, the less atmospheric goop you have to look through. Fortunately, out there, there's not too much goop. Around here, we have lots of goop called humidity. It gets pretty awful around here. So you can see the flip flat is closed now. So we are definitely using the big scope. And it should be happily collecting photons right now. And we are guiding. Oh, it looks really good guiding there too. And off we go. So let's go ahead and stop sharing for a while. And again, we welcome other questions and comments.
Yeah, one question. When you take a picture, how do you decide what color to give to the picture? Is it a guideline there?
Yeah, there are no specific guidelines. It's basically how much time you might have in terms of imaging, but usually most of us take an equal number of images through the red, green, and blue filters. Some might do it a bit differently, but basically it just comes through experience or preference. There's no must way to do it.
Hey, Richard, I was going to ask you a question the other day. So this is off of this subject, but you're talking about the star classifications. Are there any O-type stars that are visible at mid-northern latitudes?
Of course, the really famous ones are the trapezium stars. Those all are type O. One by itself, none that are really prominent. There's none really close by. They're all pretty far away. But the most famous ones are the trapezium stars. There are probably some I'm forgetting that are also kind of well known. But that one at the heart of the Cocoon Nebula, I mean, that's pretty close. It's a B1 star, really close to being type O itself. Like maybe an O9 if it were just a little hotter.
Okay, thanks. Because I didn't see any of them listed on that diagram, so I thought okay, thanks.
And they are rare. I forget the exact percentage, but of all the stars in our galactic neighborhood, up to a radius of maybe 1,000 light years, 0.00004 zeros and a 3% of all stars are type O. So they are extremely rare because not every group forms them, not every cloud forms them, and when they do exist, they die quick. I do know that around the Cone Nebula, the Cone or Foxfur, lots of several of those are type O too. We haven't done the Cone Nebula yet. Maybe we'll try that next month. If it's high enough. It should be high enough by the time we come back for next month because it's we kind of take an extended break here and don't come back till late January. I think I did see something in the chat. What should I look for in a 1.25" H alpha filter? Okay. Of course, you should look for the narrow slit. You know, the 3 nanometers give the finest images, but they're the most expensive. But you know, if you're looking to save a bit of money, usually 5 nanometer is pretty good. But there are lots of places that make them. One of our members at our Astrophoto SIG meeting, he mentioned a good source for filters from Antlia. You know, Astrodons are pretty high end, but Antlia had much better prices. But there are many sources of good narrowband filters today for imaging. Of course, there are H alpha filters for visual viewing, but they're not really meant for viewing.
Richard, I'm looking at the sky chart for this object.
Yeah.
And I see that Stephan's quintet.
Yeah.
Is just below the object.
Yep.
Will there be a chance of seeing that?
I don't think
image.
Not in the way that we frame it. I think if I put 7331 like way toward the top or the bottom, we could probably squeeze it in.
Oh, okay.
But yeah, we could try to do that after the session here. I've done it before. It's small.
Yeah. Okay.
All right. It looks like we're ready. So you guys ready to see NGC 7331? Here we go. And the fleas, of course. Don't forget the fleas. There it is.
I think we're seeing the
I
transition.
don't see anything.
Oh,
Just see
hang
the
on.
logo.
Oh, I forgot to share the screen. That's the first time I did that tonight. Okay, here we go.
Ooh,
Nice.
Oh,
that's
there.
nice.
Yeah.
Is there a thing right next to it?
Another
On the
galaxy.
right?
Yep, these are the fleas that I mentioned.
Nice.
Yeah. How do you spell that?
What do you mean? Which
I mean,
part?
like, please?
No, fleas, like on the like on a dog. FLEAS.
Oh, the itchy
Yeah.
kind.
Yeah, the itchy kind. Yeah.
Is it like a mini
Galaxy.
galaxy?
It's a galaxy. This is a more distant galaxy cluster. Yeah.
Oh. How many galaxies are we looking at?
At least one. Of course, the big one. 1, 2, 3, 4, 5. There's a 6th one up here. Maybe a little faint one there. Could be number 7. So there's quite a few in this part of the sky. It's a galaxy-rich region.
Do we know anything about any of these galaxies other than like what they're made out of, or?
Well, basically the same stuff that our galaxy is made out of. You know, stars, gas, dust,
Do we know
planets.
anything about like any exoplanets or
No.
that might exist? Oh, okay.
There was a recent announcement that we may have discovered the first extragalactic exoplanet, but that's in the galaxy M51. These are probably too far away to find planets anytime soon. I would think so, but you never know. So as you can see from the image here, the core of the galaxy appears to be slightly off center. And this belongs to the Pegasus spur of galaxies, a small gathering of 55 systems that includes, as Becky mentioned, Stephan's quintet, which is a very famous cluster of galaxies. Oh, here we go. It is classified as an SBC galaxy. So I was pretty close. SB is basically right, which means it's a spiral with, you know, kind of intermediately tightly wound arms. The spiral disk is tilted 22 degrees from edge on. It has a diameter of 120,000 light years. So from one end to the other, it's 120,000 light years across, fairly comparable to our home galaxy. Some people say the Milky Way is 120,000, but some say it's only 100,000 light years across. And it has a total mass of 300 billion suns. Stephan's quintet is 1.5 degrees south-southwest, and it's kind of scrunched into, again, 3.5 arc minutes of the sky. It's named for Eduardo Stephan at the Marseille Observatory, who discovered this, or it's named for the discoverer, Eduardo Stephan, in 1877 at the Marseille Observatory. That's specifically Stephan's quintet. So maybe we'll do Stephan's quintet as a bonus.
Well, the other thing that Stephan's quintet is famous for is the opening scenes from A Wonderful Life.
Right.
So it's the Christmas season.
Yep. Every time I watch that movie with my mother, I kept telling her that Stephan's quintet, and she tells me I'm ruining the whole movie for her. All right, so let's scroll down here. I'm going to type in the designation of our last designated target, NGC 206. And we'll again do 5 minutes to the luminance filter, and off we go. All right, so NGC 206 is what I will call the Andromeda star cloud. So we're going to look at a star cloud, but not in our galaxy, in another galaxy, specifically the Andromeda galaxy. The cloud itself is cataloged as A78 because A stands for association, because it's really an association of stars. And it was first noticed by William Herschel, the famed observer, in 1786. And it is the brightest star cloud in the Andromeda galaxy as viewed from Earth. So in short, we're going to look toward the Andromeda galaxy. We did look at this last month, and I'll even show you the image we took last month. So we're going to work from Alpheratz here, go to the 2 stars here in Andromeda, the 2 stars here, and just kind of point up. And you can see the Andromeda galaxy with the unaided eye, even from moderately light polluted sites. But, you know, from a location where we observe at the Nature Center, it really helps to have a good pair of binoculars. And more specifically, here's where we're going to look. So we're going to look at the little green square, but we'll basically take in the field of view that's shown here as well. So that's, I didn't mean for this to be approximate, but it's pretty close. So we're going to look 1 degree above New Andromedae, and NGC 206 itself is located 42 arc minutes south-southwest from the center of the Andromeda galaxy. So more specifically, here is the image of the Andromeda galaxy we took with the Takahashi last month. So if you did join us during the last online viewing session, this is our most recent image of the Andromeda galaxy. So here is the nucleus, basically downtown Andromeda. There's a black hole with 100 million solar mass in there. And we're looking right here. This is NGC 206, this bright knot in the disk of the galaxy. So that's where we're going to look. And let's check in to see how we're doing. We'll see where the telescope's pointed. Oh my goodness, it's pretty high. So we're looking pretty much right toward the zenith. I hope that doesn't give us issues with the guide star.
Hey, Richard, I don't think you're screen sharing.
Okay, let me just start over here again. Can you see the scope now? It's straight up.
Yeah.
Okay. Oh, and you can see the power light blinking on the camera. That's good. That tells us the video hasn't froze. So we are looking pretty high. Let's see how we're doing with a guide star. No, it's doing okay. It's a little rough, but we're doing good there. Okay, while we're waiting, let me do the closing announcements here. Somebody mentioned about using the telescope. So of course, If you do live within the Southwest Michigan region, one of these counties here, this is my home county, Kalamazoo County. You can join the KAS and use the remote telescope. As mentioned, it is really easy. You just have to read the user manual and watch a training video, and you can start taking pictures. And also, if you pay to use the scope, you get access to our cloud account, and you can download every image the telescope has ever taken, at least every good image. I tend to try to clear out the really bad ones.
Yeah, we're just looking at the control computer, not the map.
Man, do I keep forgetting to share the screen or what? I thought I
Well,
did.
you keep switching between screens.
I'm
There you go.
usually I'm very efficient at that.
That's true.
So yeah, you have to live in one of these counties here to use the scope. And I do want to mention, we are going to take a bit of a break here. I really wanted to do the sessions at the end of November and December, but of course, those weekends were Thanksgiving and Christmas, because the moon works out a little better. And so we're going to come back on January 29th with a cloud date of January 30th. But after we get past the winter solstice, of course, days will start to get a bit longer again. So we're going to start at 9 o'clock, as you can see there. You can go to our website and register right now if you want to. I meant to get my hands on the registration link, but if anybody wants to, maybe any member wants to run to the website real quick and paste in the registration link, that would be fantastic. If you are not already on there, of course, members don't need to join. You get the emails separately. But if you are a non-member, you can join the online during session email list. You will receive reminders about the sessions, of course. You'll get the registration and YouTube links. You'll get the link to download the session images, so you don't have to like type it off or write it off the screen here. And you'll get, of course, notifications of postponements or cancellations. Thankfully, we haven't actually had to outright cancel a session yet, just postpone quite a few. So you can use our contact form to ask to be added, or you can just send us an email at our main email address here. If you do have an interest in astrophotography, you can attend our next astrophotography SIG meeting on Friday, December 17th at 8 o'clock. This is actually our last event of the year. One of our more dedicated imagers, Pete Mumbauer, will be telling us about another image acquisition program, but it's much more, called Sequence Generator Pro. So he'll be showing us the ins and outs of that very, very handy program. And everyone is welcome to join us for our January general meeting on January 7th at 7 o'clock Eastern time. Our guest speaker will be Dr. David Williams from Arizona State University, Tempe. He is also a co-investigator of the Psyche mission. So Psyche will be our first mission to a M-type asteroid, which is a metallic asteroid composed of iron, nickel, and stuff like that. So that'll be very exciting. And he'll be filling us in on the mission on January 7th. And our meetings through at least I should say our speakers will be via Zoom through at least June. I don't know when we're going to be able to meet in person. And of course, I want to mention the Introduction to Amateur Astronomy Lecture Series, a 5-part series, returns on January 15th, and registrations are going pretty well. But I heard the bonk bonk, so let me go back to the PowerPoint screen here. And it looks like we got it. So let's click on there and see what happens. Tracking looks a little rough, but that looks pretty good. So there we go.
Yeah. Very nice.
So this is like one whole side of the Andromeda galaxy. And you can see the star cloud right here, right in the center. So NGC 206, our star cloud, spans about 4,000 light years across. It contains more than 300 stars brighter than about with an absolute magnitude of minus 3.6. Of course, the actual stars as we view them are much fainter. The youngest massive stars are less than 10 million years old. And it was originally identified by Edwin Hubble as a star cluster, but today, due to its size, it's classified as an OB association. So Joe was asking about O-type stars. So OB associations have many O and B type stars. And you might ask about, what is a association? So basically, they're exactly like an open cluster, except for one major difference. Both associations and open clusters form at the same time. They're at roughly the same distance, have the same chemical composition, but open clusters are bound by gravity. Associations are not. So associations tend to drift apart in just a few million years, while open clusters, as mentioned with the Pleiades, can last for hundreds of millions of years or more. So these stars are not gravitationally bound, but they did form together. So it's located in a zone free of neutral hydrogen and has a double structure. One region has an age of 10 million years and includes several H2 regions, emission nebulae, in one of its borders. The other has an age of between 40 and 50 million years, and that includes a number of Cepheid variable stars, which are a type of variable star that's very handy for measuring distances. In fact, it was a Cepheid variable star that we used to measure the distance to the Andromeda galaxy for the first time. So the tracking was a bit off on this one, but overall it looks pretty good. Tracking tends to be a bit rough near the zenith sometimes. But heck, we can always take another picture. Let's go ahead and try it again. Oh, I scrolled too far. So we'll just go ahead and take another one because it's not quite 10:30 yet. But since it is Sunday, not Saturday, I was going to try to wrap up a little early, at least wrap up officially. So did it start? I think my mouse is starting to go here. Let's try that again. Oh, okay, so it's already doing it. Okay, that's good. All right, let's go back to where I was. So again, I just wanted to mention that our lecture series begins January 15th. We're hoping it'll be the success it was earlier this year. It was incredibly successful. And the last thing I wanted to mention, of course, as you're dying to know, here is the link to tonight's images. Of course, you can't go to this link right now because there's nothing there. But as soon as the session is over, I will download the pictures and process them and upload them at this link. For those of you that have been attending last year and this year, I changed the format a bit. Instead of the date, I just put in December 21 online viewing session because I realized, yesterday when we had to postpone that, hey, I'll have to change the date that I already emailed everyone out. So this version doesn't depend on the exact date that we take the pictures. So I will keep this up here for a minute or two. But again, if anybody has it handy, you can throw the link into the chat for me. That'd be very much appreciated. But again, if you're a member or you're on the online viewing session email list, you have this link already, so you don't have to write it down. So I think we got a guide star. Hopefully we'll do some good guiding and we can try to take another picture here. But again, I just want to thank everyone for joining us tonight for our online viewing session. I hope you join us on January 29th, whether